So today one of our main focuses of our lesson is learning how to factor. Before we even begin, I just want to stress how important this skill is, being able to factor quadratics from standard form, which basically means putting a quadratic from standard form into the factored form, the two sets of parentheses. And this is a skill that you're going to be using throughout the rest of our course this year, as well as Algebra 2 moving forward. It's just one of the most important skills in Algebra 1. So it's very important that you're taking this seriously, you're really watching these videos fully today, and you're putting in your best effort trying and practicing on your own. Additionally, if at any point when you're working through today's lesson you're feeling confused, please go on Google Meet so I can help you directly one-on-one. All right, so let's go ahead and get started. When we are working with a quadratic in standard form, we see this is the base form, ax squared plus bx plus c. We know that sometimes a standard form does not have all of these three terms. So in a quadratic, there are two factors. There's two values that are factors, and we'll often see this in factored forms such as x plus 1 and x minus 2, or whatever those values are, but this is factored form and we have two factors. So our two factors in our quadratic we are going to call a and b. Do not get that confused with our ax squared plus bx plus c. These are completely different values, which is why I'm indicating them using lowercase values. And our ax squared plus bx plus c I've written using uppercase letters. So this is just kind of like factor 1 and 2, a and b. We know that our two factors, a and b, when added together equal our b term, our coefficient in front of this x value. This is something we just learned in the last activity. So when we add up our two factors, it gives us this value here in front of our x term. When we multiply our two factors, a times b, it gives us our c term, that constant value in standard form that does not have a variable on it. So when we're given a quadratic in standard form, using these rules, knowing that we need two values that will add up to be my b term and that will multiply together to equal my c term, I'm able to then find my factors for my quadratic. So there's a few different steps, 4 steps, that when looking at these steps, and I'm going to attach a picture, are really going to help you to be able to factor quadratics. And I'm going to go through 3 examples with us after this so you really get the idea. So step 1, it's really important to identify the b and the c values from standard form. We need to know what these b and c values are, so we need to know how to find a pair of numbers that fits those restrictions. So 2 numbers that will add up to be b and 2 numbers that will multiply to be c. So it's one pair of numbers that needs to be able to do both. Then we're going to find all the pairs of factors for c using a factor sheet linked. Next to this YouTube video here, in the slide, you're going to find a link to this online factor sheet. It has all the pairs of factors for every single number listed 1 through 100. This is going to be extremely useful for you so that you do not have to make a factor tree for every number. So this is a tool that's really going to help you out. Step 3, we're going to determine which pair of factors will add up to b, and lastly, write it in factored form. So I know that seemed like a lot right now. We're going to go through some examples, walking through it step by step so it's less confusing. So looking at this first example here, which is going to be similar to 2 of the questions you're going to answer on your own. We are given this standard form, x squared plus 5x. So we need to factor this. Step 1, I'm looking at my steps. It says identify the b and c values from the given standard form. Okay, so my standard form is x squared plus 5x plus, we don't have a c value, but again, whenever we do not have a c value, this is like plus 0. So my b value here is 5, the coefficient in front of that plane x. My c value, my constant term here that wasn't even originally written, so we know it's just 0, is 0. So my constant c value is 0. This is an important step 1, being able to identify those b and c values. Now let's look at step 2. It says, find pairs of factors for c. Use the factor sheet linked. So this is an interesting scenario because my c value is just 0. So my factors for 0 is any number that exists and 0. So we're actually going to skip this step for listing all the factors because it's not going to be super helpful for us in this way. But we do know that one of our factors has to be equal to 0, zero product property, if our c value is equal to 0. So let's go ahead and assign our a factor as 0 because we know one of them has to be 0. Now my b factor has to be a number that a plus my b factor has to add up to 5. So if we know a is 0, what plus 0 is 5? It has to just be 5. And that's it. So now that I have my two factors, what I'm going to do is I'm simply going to write my answer in factored form using my a and b. So factored form we always have, we can write it out with two sets of parentheses. And it's always in the form of x plus a value. My first factor is 0. So I'm going to have x plus 0. I feel like this is not focusing. Okay. My second factor, b, is 5. So I have x plus 5. So using our rules, it appears that we now have put my standard form into factored form, which is great. But what we need to do now is check our work using box method or distributive property to make sure we factored it correctly. So I'm going to quickly go ahead and use my box method. I have x, I have a 0, I have x and a positive 5, so I'm going to label the other side. And I'm going to use my box method to multiply it out. X times x is x squared, x times 0 is 0, x times 5 is 5x, and 5 times 0 is 0. When I combine the two terms here, neither are like terms, I get my final answer, x squared plus 5x. And it matches what I had up here, x squared plus 5x. So my factored form of the quadratic, my final answer of factored form was correct. All right, let's go ahead and do another one. We have x squared plus 11x plus 18. So I'm going to pull up my steps to solving this. I'll put it down here actually. So step 1, identify the b and c values from the standard form. So again, these are my b and c values. So I'm going to look up here. My b value is the value in front of the plane x. So my b is 11. My c value is my constant, 18. Excellent. So that's step 1. And again, I will be attaching these steps on the PowerPoint as well so that you can follow these steps step by step as you go through. Now step 2. Find the pairs of factors for c. We're going to use the factor sheet, and this is not 0, so we're doing good. I'm going to go ahead and look at my factor sheet and list out all the factors for 18. So my factors for 18 are, I'm looking at my factor sheet, and I have 3 pairs of numbers. I'm going to write down all of those 3 pairs. I have 1 and 18, I have 2 and 9, and I have 3 and 6. Okay, so I'm literally just writing down the pairs of numbers that I see on my factor sheet. And we're done now with step 2. Now, step 3, determine which pair of factors adds up to the b value. So again, what's my b value? My b value is 11. So I need to find what pair of numbers, when I add them together, equals 11. Is 18 plus 1 11? No, it's not. Is 9 plus 2 11? Yes, it is. Is 6 plus 3 11? No. So this is the pair of factors that works. When multiplied together, they equal my constant, 18. When added together, they equal my b value, 11. 9 times 2 is 18. 9 plus 2 is 11, so it works out. And again, I found this following my step-by-step instructions. So here, it appears that my pair of factors is going to be a positive 2 and a positive 9. So in factored form, I'm going to go ahead and write that out. So, and I just forgot, I'm going to label my A and B as 9 and 2. It doesn't matter which one you assign to which. And then I'm going to label out my factored form. So factored form is always in the form of, we can do two sets of parentheses. It's always x plus a number. Sometimes it might be plus a negative, so you could just write that as x minus, but the general form is x plus a number. So I have x plus one of my factors, 2, and I have x plus my other factor that I haven't written yet, 9. And there I have it. So this should be my final answer, writing this in factored form, but we're going to use box method or distributive property to verify that we've done it correctly. If you skip this step of checking your work, you'll often end up with mistakes. So it's very important to check your work. This time, I'm going to use distributive property since I did a demonstration of box method before. So I have x times x, which is going to be x squared. Then I have x times the 9, which is going to be positive 9x. Then I have 2 times x, which is positive 2x, and 2 times 9, which is positive 18. My last step is just to add like terms. 9x plus 2x is 11x. I end up with x squared plus 11x plus 18. Now, is this matching what my original standard form was? X squared plus 11x plus 18? Yes, it did. So I could conclude that I did it correct. This is my final factored form, x plus 2, x plus 9, that I was able to figure out given the standard form. All right, one more example here that I have for us that's a little bit different. Here I have x squared minus 11, and oops, I meant to write an x here, wrong letter. So x squared minus 11x plus 10. So again, I'm going to follow my step-by-step instructions. Something that I really recommend for you guys is, in addition to referencing back to the photo that I'm posting, is that you're actually hopefully writing down these steps in your notebook so that you're able to use those step-by-step instructions on your cool down today as well as on future exams. All right, so last, we have x squared minus 11x plus 10. Step 1, identify the b and c values from the standard form. So my b value here is negative 11. My c value is 10. So my b value is negative 11. Notice how I just write the coefficient in front of the x. I don't write negative 11x. I just use that value. And I did not ignore the sign. It's a negative 11, okay? Negative 11. And then a positive 10 for my constant. So I'm done with step 1. Now, step 2, find the pairs of factors for a c. Use the factor sheet linked. So again, I'm going to pull up my factor sheet and I'm going to list all the pairs of factors for 10. So I have 10 and I'm going to list all my pairs of factors. So 10, the number 10 here, has 2 pairs of factors, 1 and 10 and 2 and 5. So I'm going to list out that pair. I have 1 and 10 and I have 2 and 5. Good, so I'm done with that step. I listed out my factors for C. Step 3, I need to determine which pair adds up to the b value. So my b value is negative 11. This is where it gets tricky. I don't have any negative numbers here. What's important to recognize is that when we're looking at the factor sheet, it's only going to include positive values. However, any of these numbers could be negative. Since my c value here is positive, that means that I need to either have 2 positive factors or 2 negative factors, because a negative times a negative will give me this positive value. So, playing around with it, I need some variation of 1, 10, or 2, and 5. So, will 1 and 10 in any way add up to be negative 11? So let's see if they had negatives on them. Negative 1 plus negative 10 does equal negative 11. 2 and 5, in no way, shape, or form, with negatives or not, will those absolute values ever combine to be the value of 11. 5 plus 2 is 7, 5 minus 2 is 3. There's no way I'm going to reach that value of 11 or negative 11. So this is the pair of factors that I need to work with. The key here is to determine now how we can assign these values with negatives. So again, looking that 10 is positive and that these two values, these pair, have to multiply together to equal a positive 10, that means that both of my values have to be positive or they both have to be negative. If they're both positive, 10 plus 1 is 11, but it's not negative 11. If they're both negative, which we already tried, we know negative 1 and negative 10 does equal negative 11. So my pair of factors that we're going to use is actually negative 1 and negative 10. So I have my answer. I have x plus negative 1, and I have x plus negative 10. As we've already learned, when we have plus and negative, it's the same thing as just writing minus. So this is the same thing here. It's just doing x minus 1 and x minus 10. I prefer to write it like this instead of having all of these different signs. My last step here is to check my work by using box method or distributive property and make sure that my factored form does match my standard form. So my first step is I'm actually going to use distributive property for us here so that we can start getting the hang of that without box method. So I have x times x is x squared, x times negative 10 is negative 10x, negative 1 times x is negative 1x, and negative 1 times negative 10 is positive 10. So I have x squared minus, these combine to be negative 11x, and plus 10. And I did it. So I was able to match my x squared minus 11x plus 10. It works. So this here, the x minus 1 times x minus 10 is my final factored form. If you feel overwhelmed with how we're supposed to identify these negatives, I want you to just play around with it. So once you get those pair of factors, see if there's any way you can combine those values with any negatives on any of the factors to fit the restrictions of adding up to be the b value and multiplying to be the c value. This is the first day we're doing this, so do not stress. We're going to have several more lessons practicing this, but please do your best and follow this step. So don't forget to reference this paper here with our step-by-step guide, as well as your factor sheet. That's going to be very important. So I'll have it all posted and linked in the slider for you so that you can go ahead and work on it in the next activity. I know this was a long video, but again, it's super important, and please see me in Google Meets if you have further questions or need help.